Okay, so let's continue. So we talked about protocols, layers, peer processes, and so forth. So let's continue on this by summarizing layers again. So layers is a set of related communication functions to provide a service to the layer above it using service layer below it. Now, I said it like 6 times this lecture, and you all got it, right? But I will probably continue to say this because it's so important, so fundamental to understanding how things are working in practice. So when in confused, one can always go back and say, okay, but the main idea here is that the protocol should provide services up in the stack using services below it. And then one can usually figure out how things work. Okay, now, so let's go on and look at more on services in detail here. And how one can structure these layers. What are the functions and where should they, in what layer do these functions belong to? And here there are 2 main approaches. One, which is called the Open System Interconnection Model, OSI model. And it's a reference model that has 7 layers in it. And it's very, very influential in the sense that it establishes a way of thinking. However, it's not used in practice. Okay, there are protocols and so forth being designed and so forth, but they're very, very seldom used. Then there is the internet reference models, which has 4 or maybe 5 layers, depending on which book you look at. And it's quite empirical in the sense that it was organically developed when the internet was created, starting from a research networks in the 60s, maybe even in the 50s, and then it evolved into the internet, the pervasive way of doing things on the internet as we have it today. So it's been growing, and therefore it's not being thought out before and then designed. It sort of grew up, right? So it's a little bit, it's heavily used in practice, but it's a little bit more, it's more messy than the OSI model, okay? So the approach we will take in this course, and I think this makes a lot of sense, is that if one wants to talk about layers and protocols in a more, how they really should work, one can talk about the OSI model. But then, of course, how things are actually run is doing the internet model. So the internet model will violate some rules that we have talked about in the OSI model, or actually the rules that we have been talking about earlier here to some degree. But that's just the way it is, right? To understand how things are or should work to some extent, one can look at this. And then if one wants to do things more in practice, one has to go in here. And then there are certain things which are a little bit violated, I would say. Okay, so let's start with the OSI model. And it has 7 layers. And then the task of providing connectivity over a network is then divided into these 7 sub-problems. On top, we have the application layer, just as we talked about earlier. And it provides services that are frequently used by application programs. For instance, find me the IP address of this web server, or please use HTTP to connect to a web server and get some files. Then there are two layers here, presentation and session layer here. And these are dealing with things which are important also. So presentation is conversion between different data representations. For instance, sometimes there is a file in ASCII, and sometimes it's a file in some other encoding. So it's a translation services of this. And then session is for dialogue management, how to create connections and take them down and so forth. We'll leave it at that for this moment. And then we have the transport layer here. And the transport layer is very important. It's responsible for creating an end-to-end connection. So to make sure that data can be transferred from one end of the network to the other end of the network. The network layer is responsible for transmission of packets, data over several links. So the routing, for instance. And data link is to transfer of data over a single link, and the physical layer is responsible for actually formatting the bits in the message into some type of electrical or optical or radio signal that fits the medium that we have at hand. The internet model here. Oh, sorry. First of all, the thing is with this is a nice structure. However, as time evolved, it was pretty clear to most people that the presentation and session layers were so thin, they did not, that they are essentially, there was questionable whether they should be a layer of their own. So in most cases, one lumps all these 3 top layers into one single layer. However, one still called that the application layer, and one still called that layer number 7. Okay. So here's 1, 2, 3, 4, 7. Okay. It's just the way it is, right? So the presentation and session layers are usually absorbed into the application layer here, and the numbering remains the same. Okay. How is protocol messages structured? So a protocol message typically consists of the following things. It consists of a header, and that header has some type of control information which is useful for the protocol to be executed. But it does not carry the data from the layer above. So if we all think that we are in layer N here in this room, we get some data from the layer above, okay? And that data should be transferred. And that data is called data field or payload sometimes. So we get that data from the layer above. Now, so I get this data, so I'm a protocol entity, and then there is a protocol entity somewhere on the other side of the building that I want to transfer this information. I get the information from above, and then I would just like to transfer it horizontally like this. For this to work, I probably need to slap on an address on this data, right? So it knows where it should go and so forth. So there is addresses, maybe sequence number, other type of control information. And that is put into the header of the packet that I actually transmit. So this is typically always the case. I take some data from above, and then I attach an address or other control information to this in the header, and then I send it off on its way. Okay, so the data which is transmitted in a layer consists typically of a header and then user data. And user data or payload is what comes from above. Okay, and header plus data is what I transmit horizontally, logically, in between the protocol entities here. On some layers also, it's important to put the trailer here also onto the payload. So this is not used in all layers, but in some layers. And the reason for this, it will be obvious later on. Okay. But it's also in order to send the data in this particular layer. Okay. At the transmitting node, headers and trailers are appended to the packet as it travels down the stack. Okay. So suppose that this is the transmitter side that wants to transmit some information, and this is the receiving side. Okay. So this is at some other physical position than this is. They both have a protocol stack consisting of 5 layers here. 1, 2, 3, 4, 5. Okay. And the application protocol entity here would like to talk to the application protocol entity here. So there is some horizontal communication going on here. Or actually, we start from the top. There is an application program here. Think of this as a web browser that would like to talk to a web server here, web server software. Okay? And it wants to send some data. This data is then pushed down here into the application layer and to a specific protocol here. For instance, HTTP. It could be something else, but say HTTP in this case. And then HTTP, what it does, it attaches some data to this one. If you remember what we said get right? And then we had the URL, which was given from above. And then there was something at the end said, okay, I'm using HTTP 1.1. Okay? So there is some information which is specific to this protocol, and that's put in the header. The application data is not touched at all. Okay? It's not interpreted, it's not touched. To figure out addresses and so forth, that comes separate as a separate channel here with control information from the layer above. Okay? Okay, so the application layer wants to send this to the application. The application layer entity here would like to communicate with the application layer entity here. And it does that using the service of the transport layer. So then the data, we're still at node A here. Nothing has been transmitted yet. Okay? So node A then pushes this down to the transport layer. And the transport layer adds its control information to this. Okay? And then this process is repeated. The network layer puts on the network header. And the data link layer puts on a data link header and typically also a data link trailer. Okay, so this is typically done here. Okay, so we see here that the application data here is present in all of these messages, but as we are pushed down, we are adding more and more headers and addresses to this. Right? And then the physical layer here then puts it down here, and here the physical layer has no other service to use. So it just needs to convert all these bits into a signal which is possible to communicate over the link. So here it's just considered to be bits, and these bits are transmitted. Okay? So this process of taking data when it's pushed down into the protocol stack here, that's called protocol encapsulation or encapsulation. So the protocol packet here on this level is taking the protocol packet on the above level and just puts it here and appends something. So we can think of this as that it's basically, if I'm the protocol entity, I get some data above, and then I have a big envelope that I push down the data in, and I glue it together, and then I write the address on this packet, and that's my header. And then I push it down, and this process comes down, put it in a new envelope, a new address, and so forth, right? So one never looks into the content of the envelope that I get from above. I don't look at the envelope at all, actually. Well, I look at the address in order to figure out what to do, but I don't look at the content of the letter. Clear? Okay. So what happens at the receiving side? Well, the opposite, right? So the physical layer, the bits come here. So the physical layer here say, okay, I got some bits. So I'll send it up to my boss here, the data link layer. The data link layer then looks at these bits and sees that and looks at the data link header here to figure out what to do, right? It doesn't look at the rest of it. It just looks at the data link header, okay, and the trailer also, and figure out what to do. And if everything is okay, it pushes, it strips off the headers and then push it up into the network layer. The network layer inspects the network header and figure out what to do. And if everything is okay, it pushes this on up and so forth. So we strip off the headers as we go along. Okay. So encapsulation, adding headers and trailers, and then, well, we should call it encapsulation at the receiving end. Clear? Yes?
Could you just repeat what the trailers were?
Well, the reason for the trailer here, what that is. Okay. So for the data link layer here, we're getting closer and closer to electronics here. So the physical layer here in its simplest form is just transmitting bit by bit what it gets. And then we have the header coming first in time and the trailer coming last in time. So the processing which is done here is in time going over the packet like this, the physical layer here. And the physical layer doesn't do anything than to put this up into the data link layer. And the data link layer starts to process here, and start to process and see, okay, was it for me? Yes, it was okay. And then, okay, so here comes some data, I want to send this up, and here. And now I read all the data. Is this data okay? Then we use the trailer here to check whether there has been any errors occurring here, okay? So there is some error detection code, which we will talk about later on. And if the processing then says it's okay, then everything goes up like this. So the reason why to put this could have been put at the front here, but the implementation then becomes more inefficient. So it's just an implementation issue, I would say. And we'll talk more about that later on. Okay, but that's a good question. Okay, so now a layer that OSI has this uniform view on a protocol layer. So let's talk about that. So layer N in a node interacts with layer N in some other node, or nodes actually, as we will see. And then to provide a service to the layer above it, that is for layer N+1. The entities which are in these layers are called peer processes. So here at node A, there is some software being run, a software process. It's called, let's call that an entity. And then it executes a protocol in this layer. And here we have another entity. These two entities, we call them peer processes also, or peer entities. And these are communicating with each other. The nodes use rules and conventions called the layer N protocol. Okay. There might be several entities running the same protocol, and there might be several entities running different protocols in the same layer. But they all are communicating with one other. Okay. Executing the same protocol in the same layer. Layer N peer process communicate by exchanging data, and this data is called Protocol Data Unit, PDU. Okay, so here's another acronym. This acronym we need to learn, both what it means and what it actually is. Okay, and these are called, since they are in layer N, they are called N PDUs. So there could be like 6 PDU, 2 PDU, or 3 PDU, or transport layer PDU, link layer PDU, and so forth. Typically, one does not say the number here, but one say the name of the layer. Okay, and that PDU consists of a header, which is for that layer. So suppose this is the application layer, then we have an application layer PDU and an application layer header, or a 7 PDU and a 7 header. Okay, and then there is some data, and that data is from the layer above it. Okay, so these protocol units go back and forth in order to execute the protocol, in order to provide a service to the entities which are above it. Okay, so this is a little bit of terminology. Is it clear? Okay. So connection between these processes is virtual, right? So we said we are using the services below it, so they are indirect. So the information that layer N+1, when it transmits its PDUs, what it actually using is using the layer below it. So when I want to transmit, if we are on the layer, I'm an entity, I get some data above, I put a header on that, and I send it like this. That's only the logical transmission. The physical transmission is down to the layer below it until it reaches the physical layer, and then it's actually put onto the link. Okay. So HTTP, for instance, okay, so services are available at something called service access points. And these are particular, think of these as particular holes in the roof where I communicate. I am being a protocol entity where I communicate with the entity above. Okay, so there might be several holes in the roof here because we have several entities on top of this. Right? If I want to send a packet over to the other side, if I'm the receiving entity, I get a packet here, logically, horizontally, physically from below. Okay, I get it here, and then I look at it, and in the header, it says, okay, in which hole I should put it up. Okay. So that's the service access point, because there might be several entities above, so to which one should this particular piece of data go to? These are called service access points. So an HTTP server, for instance, always listens to a hole in the roof, which is called port 80. Okay? A specific transport layer service access point called port 80. This will be hopefully a bit more clear later on. But there are some interfaces between layers, and these are called service access points. Each layer then passes data and control information to the, so if I wanted, I get some data here, I would like to send it virtually, horizontally. What I need to do is push it down to the layer below it. Then I need to instruct also the layer below it where this should go. So I need to provide some control information, addresses, and so forth. But that's separate from the protocol, from the data that I would like to transmit. The data I would like to transmit is my protocol data unit, which consists of the data I got from above plus my own header. Okay. The data which is received from the layer above, the data I get, is called the service data unit. Okay. So if we are in layer 4, I get some data from above, and this I call the layer 4 service data unit. Okay. It's the data which should be transmitted using the services I provide. Okay. And these service data units are then encapsulated in PDUs. So if you're not confused now, I don't know, right? But a picture might show what's going on. Okay. And this picture is actually pretty important. So let's try to pay attention here. So again, we know that a layer works like this. It's at some level, n+1 in this case. There are two entities, one at two ends of the communication chain, and then they are exchanging PDUs. And these PDUs are indexed by the same layer number as the layer is executing. In practice, this virtual communication runs by using services of the layer below it. So this entity has a service access point, which is the interface to the layer below it. So the layer below it has an entity, and now we went from n+1 to n. Okay? So this is a layer n entity, and it receives some information from the layer above it. That information, from a layer n perspective, is a service data unit. Okay? So this is the service, the data that belongs to the service that I would like to provide to the layer above it. So for this entity, this data is now called the service data unit. So it changes name as it goes over this border here. Otherwise, it's exactly the same bits, right? Same bits here as here, two different names for the same thing, right? But from the perspective of the nth layer here, this is a service data unit. From the perspective of the layer above it, it's a protocol data unit. Okay. So what happens with this service data unit? Well, we said this a couple of times. We put a header on it and call that our protocol data unit, and then transmit virtually horizontally like this. So the layer n PDU consists of the layer n header and the layer n service data unit. Okay. The layer n service data unit, what is that? Well, it's actually the layers above protocol data unit, PDU. Questions? Okay. So the second slide you want to watch tonight, if you're having a hard time falling asleep, is this one, right? Because this one is super important. Otherwise, it will be very difficult to understand what's going on, because there are PDUs and SDUs, and they are sometimes the same and sometimes not, right? So I can almost guarantee you that this will pop up on the quiz next week in some way or form, right? Okay. Obviously, this entity, the virtual communication, is done through the layer, using services which is on the layer below us. Okay, so these PDUs are then sent down here to the layer n-1. And when it goes from here to here, it changes name from nPDU to n-1 SDU. Right? Just as we did here from here. All right? Questions? No? Okay. And these service access points here is identifying the interface between layers. So for instance, when this entity wants to transmit this PDU, it needs to tell what this PDU is going somewhere. So it needs to, first of all, identify this thing, because the data goes down here, should go up here. So this layer needs to inform this layer that it should tell its other peer to the data that comes here should pop up in a certain hole in the roof. Okay, and there's several holes in the roof. Okay, so this is some type of addressing information. Typically, what is also specified in this request is an identifier for this thing. Okay, because then this one knows where to instruct the lower layer where it should put its data here. And this will be clearer than when looking at the specific rules for a protocol to see what is handed down. What is handed down here is both the data and then the control information, which I have not written out explicitly here, but these are addresses and things like that. Okay? So let's continue. And now these services which are provided have certain attributes, and so there are classifications of these. So again, there will be terminology that we need to learn in order to discuss this at some informed level. Okay, so the first thing, we have connection-oriented and connection-less services. So if I'm here, we're in the layer, we provide a service to the layer above it. This service has some qualities to it. It could be connection-oriented or connection-less. A connection-oriented service is something where we establish a connection before we transmit data. Okay, so one example of this is TCP, because it creates a logical connection between the layer n SAPs at the receiving end, allocate buffers and agree on transmit parameters and so forth. Okay, so what does it mean? Okay, so if I'm TCP, for instance, there is another TCP unit somewhere else, entity, and I first try to send some data to it and say, okay, we would like to put up a connection with you. Is that okay? And then one negotiate, that's okay, I'm a little bit busy, so don't transmit so much data now. Okay, that's fine, I'll try to take it slow and so forth. And we agree upon things. And then once we agreed upon this, I can tell the layer above, okay, I'm ready now, so please give me some data and I will send that over the connection. And then we do that until the layer above it here or on the other side say, okay, that's enough. And then we cut the connection. Very similar to a telephone network, right? Okay, so here, this is a organized, controlled way of doing things, almost conservative, right? We establish a connection, we agree upon things before we start to communicate. It takes time. And it also takes resources. We need to have buffers and things like that at the different nodes in order to execute this. Sometimes it's better to use a connectionless service. And a connectionless service, for instance IP, simply transmits data without any questions asked. I get some data, I get some address, I just send it away without even checking if somebody's listening. Without even checking that there is a node out there somewhere. I just push it into the network and hope for the best. Okay? And that works fine for some services, but obviously not for others. So web service HTTP uses TCP, while DNS is not using TCP. It's actually using UDP, which we haven't talked about, but it's essentially IP. Okay, and there are reasons for this. Okay, so there is a space for these, and there is a space for this. Different things, but they have different qualities and also different cost. Cheaper, more expensive, more reliable, less reliable. What to choose? Depends. Okay. Questions? No. Okay. Names of PDUs. We said we can call them 7 PDU or application layer PDU, or we can call it also a third thing. And here's the translation of this. So sometimes it's important to keep track of these, and sometimes not. But if one should be careful, then application layer PDUs are called messages. Transport layer PDUs are called segments. Network layer PDUs are called packets. Link layer PDUs are called frames and physical bits. Okay. We will be sloppy, and as soon as we have a group of bits, even just one bit, we will call it a packet. Okay. Even though packet is actually reserved, if one should be strict, for the PDUs which are reside on the network layer. Okay. But sometimes when you read how a protocol is implemented, for instance, IP, which resides here, it talks about IP packets and it talks about TCP segments, right? And that's just to keep the distinction between a service data unit and a protocol data unit clear in the terminology. So instead of saying a transport layer PDU, it says a segment. Less characters in a document. But they mean the same thing. Okay, questions? As you see, this is almost like a language course, but there is glossary that needs to be learned before one can start to talk. I'm sorry for that, but that's the way it is. Okay. A service can be using segmentation or not. And the reason for this is that a layer may have an upper limit on the size of the data it can transmit in one shot. And this is almost always true, right? So for instance, if the layer above me would like to transmit an HD video of, say, 2 gigabytes, and I get 2 gigabytes from above, and then I might not be able to transmit 2 gigabytes or rather, I get these 2 gigabytes and I stand here, okay, what am I going to do with this? I know the layer below me will not send more than 10 megabytes at the time. Okay, then I need to cut up these 2 gigabytes that I got above into smaller pieces and then push them down individually into the lower layer. Now, at the receiving end, I get the packets up here, and then I need to glue them together before I send them up. Right? That's called segmentation and desegmentation or something, or reassembly. Okay. So at the sender side, the big SDU I got, I chopped them up into smaller pieces and transmit them in multiple PDUs. Multiple PDU, SDU, PDU. Okay? And then at the receiving end, I need to reassemble them in the right order, obviously. Questions on that? Okay. So virtually, we take a big SDU, we put them into various PDUs, we transmit them individually, and we glue them together at the receiving end. Blocking and aggregation is almost the reverse process. Is that I know, when I reside in this layer, that the layer below me, let's do this. There might be here there's an upper limit on the size that what we can transmit in one shot. There is typically also a lower limit, and the reason for this is more for efficiency, because we know that all the data that are pushed down to the lower layers, there will be a header appended to it, and this header consumes resources, obviously, when it's transmitted. So if the payload is very small compared to the header, the overhead is huge. Okay. So for instance, if I want to transmit a packet, a regular box packet here to Stockholm, that's not going to run on its own train or truck, right? It's going to be packed together with other boxes that goes to Stockholm, right? For efficiency reasons, right? So same thing here in communications, right? So a layer n SDDU might be too small to be handled efficiently by a lower layer, the lower layer. So what we do then is that we take multiple SDDUs, we put them together in one protocol data unit and transmit that over the channel. Okay, and at the receiving end, I unpack this packet and I see, okay, there are multiple SDDUs here, and I send them up individually to the layer above it. Right? Clear? And it's not rocket science, right? But terminology makes it sometimes hard to be precise on what you mean. So this is called sometimes aggregation also. Multiplexing, it's when an entity that resides in a particular layer serves many entities above it. That's called multiplexing. So, so that's a very specific notion. Multiplexing is a wide term used in many different contexts. But in this context, if we say that the service offers multiplexing, so the service which is provided by this one says, if it offers multiplexing, it says it can serve several entities above it. So for instance, this might be an IP protocol, and then it can serve a TCP connection, a UDP connection, or two TCP connections at the same time, and so forth. Okay. And this is fine, of course, if at the receiving end, the receiving entity here will be able to put them up in the right hole in the roof, right? So this entity here would like to transmit its data to this entity here. So, sorry, blue to blue and purple to purple here. So when this entity tells this entity, okay, please transmit this data, it also needs to tell him, this entity needs to tell this entity to what SAP it should go. So it puts down a multiplexing tag into the header of the PDU which is transmitted. At the receiving end here, I get a bunch of PDUs. What should I do with them? Well, I look in the header and then I find a multiplexing tag here that tells me that this is a purple SDU and it should go up in this SAP, not in this SAP. Service access point. Okay. So this is multiplexing. Questions? Okay. So again, multiplexing, a service that offers multiplexing means that it can serve several entities above. Okay. Splitting or inverse multiplexing is the opposite. Is when a layer n plus one entity use multiple layer n services. It might be that this entity here has a need to transmit lots of data, okay, and the speed of the lower layer here is limited for some reason. So if we have loads of data to transmit, it can take very long time if it only uses one of these entities. So what it does, it splits its data over multiple entities. Okay. So for instance, if I don't know what would be a good analogy here. Well, say for instance that I have 2 radio channels available. This is a radio-based system, right? So I have lots of data, and for each radio channel there is just a certain data rate that could be transmitted, maybe 1 megabits per second. Then if I want to transmit my data twice as fast, I use 2 radio channels, and then I get 2 megabits per second. For the layer which is above me, it looks like I have 2 megabits per second, but I'm actually using 2 1 megabits channels. Okay. So this is called splitting or inverse multiplexing. Now, going back to the OSI model here, this is a picture which illustrates a little bit about what the different layers do and how they interact. We have 2 nodes, A and B. There are 2 hosts, two machines that are executing software, application software, user software, and they also executing the protocol stack. Okay. And the protocol stack consists then of these 5 layers, 1, 2, 3, 4, 5, 6, 7 layers. And some of these protocols, the protocol entities here are talking to the protocol entity at the other side, at the end node. Okay. But it might be the case that this computer is not physically through one link connected to this computer. Rather, that's the idea of having a network. In a network, you have many links and many nodes in between. So the data that goes from here needs to go over several hops. Okay. Regardless of this, the application layer is talking to the other application layer here right away. When we did this HTTP example, I did not know where the data was routed, over what intermediate node this went to. And I don't care. I was directly connected to the other side. So application use an entity in the application layer talks to an entity at the application layer at the end node. Okay? And this is true for the four protocols at the top here. So the transport is doing the same thing. Now, once it goes down to the network here, it's a different thing. So this network layer here actually talks to all the network layers in the intermediate nodes from A to B. Okay? And it actually does that in an indirect way. This one talks to this one talks to this one talks to this one. So there is some information flow going back and forth here, but it gets processed on the way, right? So that's the network layer, and it needs to do this in order to figure out the route, for instance. Okay, the data link layer is a little bit simpler because it only talks to the next, over the next to whatever is on the other side of the line or the link. So it talks to the next system only. So this data link talks to that data link. This data link talks to that data link, but there is seldom any information that propagates. Well, okay. But it's not responsible for routing, so it has less interest in what's going on here. This data link layer here has not so much interest in what's going on here. Okay, and then we have the physical one, and that typically talks to, there are two electronic things that talk to each other. So that also talks over link. So these are, what should we call it? These are end-to-end protocols, and these are not end-to-end protocols. Maybe it's hard to call them link protocols, but because that's typically reserved for this type of protocol. Okay. Questions? Okay. Now, lecture quiz. So what is true for encapsulation? Higher layers include lower layer packets into a higher layer packet. It's a technical term that describes that data is placed between the header and the trailer. It's lower data include upper layer packet into the lower layer packet. I actually don't know the answer myself here. So, but anyways, who's for 1? Who's for 2? Who's for 3? Okay. I mean, this is true in general. This is even more true, right? Because what is the essence of encapsulation is, of course, the data that I get above, I need to transmit that. So that needs to be included in the packet that I transmit. But encapsulation means that I don't process what I get from above. I get it, I put it in the envelope, and then I write my stuff on it. Okay, so that's encapsulation. So one could think of this maybe as saying, okay, I get the data above, and then I don't know, I process that somehow before I put it in the envelope. This was a bad quiz question, by the way, so don't worry about it. You know what encapsulation is, right? You get the data above, you put the header on it, and then you put it down to the layer below it. That's what you do. And at the opposite side, on the other side, you do the reverse process. So, but here, now it becomes tricky here. What is a typical layer n packet structure? Header n PDU plus trailer. Header plus n SDU plus trailer. Header plus n PDU. Who's for 1? Who's for 2? And who's for 3? Okay, so here's a little bit tricky, and some form of this will surely come up on the quiz here. Okay, so the thing is that we're talking here about layer n packet structure. So these are packets that transmit here, like this. Okay, so we're talking about the n layer PDU. What is the structure of that? Well, the n layer PDU is not the n layer PDU plus a header. Okay. Actually, this is the right answer, right? We have a header, we have a service data unit, and we have a trailer. And the service data unit is what I get from above. Okay. It's not header plus layer n PDU because the whole thing is the PDU. How do I figure this one out? I look at this thing here. The NPDU, NSDU, N header. Okay. What is this? It's the N plus 1 PDU. So you realize that we can do quiz questions here with many variations. Okay. We're running out of time here, I see. So I will. We have a lecture in 15 minutes also. So how about if we take a break now, and then we continue with this.